Let's talk about graphs. What exactly is a graph? A graph is a indicator. A graph is something that shows us potentially information that is potentially complex to be shown, or information that is tedious to otherwise compile in a simple form. So, like last year, we saw a concept called bar graph, through which, for example, we could easily resemble the yearly population, possibly in crores. Or those of you who are cricket fans or IPL fans would know that to compare the run rates of the two teams, we have a fluctuating moving graph that is shown to us after the advertisement of every over, so on and so forth. In physics or in physical world, also the concepts that we have started for this chapter, we can sort of try and understand or make sense of through these graphs. So the first kind of graph we are going to see is the distance time graph. Distance versus time graph, meaning distance on the y-axis and time on the x-axis. Distance could be either in kilometers, it could be in meters, time could be in hours, time could be in seconds. So for uniform speed, mind you, what is uniform speed? Uniform speed is the distance or coverage of equal distance in equal intervals of time. So for uniform speed, there is a straight, it's resembled by a straight line emanating from the origin, because it's equal distances in equal intervals of time. So it is on scale, so to speak. On the other hand, for non-uniform speed, meaning unequal distances in equal intervals of time, there is a fluctuating graph, or there is a fluctuating curve, because although the intervals of time may be the same, the distances are variable, increasing or decreasing. Then coming to velocity time graphs. Velocity time graphs are y-axis velocity, x-axis time. Velocity could be in kilometer per hour or meter per second. Time could be in minutes, hours, or seconds. Uniform acceleration and non-uniform acceleration is, let's rewind. Uniform acceleration is equal velocities covered in equal intervals of time. Non-uniform acceleration is unequal velocities covered in uniform in equal intervals of time. So equal velocities in equal intervals of time, uniform acceleration can be again represented as a straight line emanating from the origin, just like uniform speed. For non-uniform acceleration, there are actually two cases. Non-uniform acceleration, as you know, is also negative acceleration or deceleration. So for an already moving vehicle which is suddenly stops with a thud or suddenly stops with a jerk, this would be the nature of the curve, while this would be non-uniform, which is not increasing or resembling equal velocities in equal intervals of time. It is first increasing, then decreasing, then again increasing.